Hey guys, today we're going to talk about identifying transformations. So this is going to be a short lesson because we've already done some of this a little bit last week via ChargeUp, and we got pretty good at it, so today's just going to be a little bit refresher. Alright, when you're thinking about identifying transformations, you need to think to yourself, how did I get from one side of my graph to another? So if I have a shape, we'll just make it a square, that starts out on this side, and ends up over here, how did we get here? Has it been rotated? Has it been translated? Has it been reflected? And that's what I want us to think about as we look at today's examples. Alright guys, let's look at this one. Figure G and figure H and a line are shown below. Ping believes that figure G and figure H are congruent. Which of the following best describes how Ping could move figure G so that it exactly covers figure H? So if I look at my answer choices here, I see that I'm looking at whether or not it's been reflected, translated, rotated, and then translated, rotated, and then reflected. And I immediately see that if I look at my shapes, H and G, they're opposite each other on opposite sides of the line. So I definitely know that it's been reflected. So I can go ahead and eliminate answer choice B. Now, answer choice C is saying it's rotated 90 degrees clockwise. Well, if it was 90 degrees clockwise, my triangle would look like this. It would be lying on its side, on either side. So that one can't be right. Rotated, and then answer choice D is rotated figure G 90 degrees clockwise, and then reflected it over the line. Again, that would give me a sideways triangle, so D can't be right. So that leaves me with answer choice A. This figure has just been reflected, which makes sense because it looks like the opposite. Let's move on. Alright guys, let's look at this example. The first thing that I need to look at is which one of these triangles is my original. And if I look super close, I see that this triangle is ABC. There are no prime marks on it, so that has to be my original. If I look down at this second triangle, this one has one prime mark on each of its letters of A, B, and C, and this last one has two prime marks. So I know that this one is my end result. So I need to ask myself, how do I get from my original triangle to triangle A prime, B prime, and C prime first? Because I know that this is going to have at least two transformations. I can see initially that A, B, and C are not in the same position as A prime, B prime, and C prime. So this could not have just been a translation. If it was a translation, A would still be pointing up. So, and I also see that it's moved over more than one axis, which means it would have gone over the x-axis and over the y-axis. So it couldn't have been a reflection. So that leaves rotation. And I know that a move from one quadrant to the diagonal quadrant is going to be 180 degree rotation. So that's our first transformation. Now I need to figure out how I get from A prime, B prime, C prime to A double prime and B double prime triangle. Now, again, I need to ask myself, is this a translation, a reflection, or a rotation? I can cancel out translation because the letters do not have the same orientation. If they did, they would look exactly the same. They'd be pointing the same way and everything. So I'm going to try reflection. And to see if it's a reflection, I'm going to count the distance from C prime to the axis and C double prime to the axis and see if it's been reflected. So C prime is 1, 2, 3 spots away from our x-axis, and C double prime is 1, 2, 3 spots away also from our x-axis. So this triangle has been reflected over the x-axis. And again, you would write this in complete sentences. All right, guys, the best way to get better at this is just to practice, so let's go ahead and do that.